Okay, so we're going to talk about nuclear chemistry, focusing on half-life today. And to begin, we need to talk a little bit about what nuclear decay is. So, nuclear decay is the spontaneous process of nuclear transmutation, which is the changing from one element to another. All isotopes that undergo nuclear decay have a half-life. Which is the length of time it takes for half of the isotope to transform into a different isotope. So let's start out here by looking at the alpha decay of Actium-225. So here's a picture of the alpha decay of Actium-225 and the equation for Actium-225. We learned how to write nuclear decay reactions and transmutation reactions in the previous video, so you should check that out if you don't understand what you're seeing there. And what we have here is the half-life of Actium-225 is 10 days. So we're going to try to explain what this concept of half-life is. So I'm going to make a little grid here and write in time elapsed and amount. And at 0 days, when we start off, let's say we have 50 grams of Actium-225. Well, 10 days later, since the half-life is 10 days, we're going to have half as much, which is 25 grams. Another 10 days goes by, we're going to have half of what we had, which will be 12.5 grams. Another 10 days goes by, we'll have half of what we had, which will now be 6.25 grams. You can see here on this graph how the half-life works. Every 10 days, you cut the material you have in half. Now, it's important to note that this is the half-life specifically for Actium-225. Each isotope has its own unique half-life. So let's just do a sample half-life problem just to try to reinforce the concept here. So the half-life of zinc-71 is 2.4 minutes. As I said, each isotope has its own unique half-life. So if one had 100.0 grams at the beginning, how many grams would be left after 7.2 minutes? So the way we're going to go about doing this is we're going to set up a little equation, and we're going to start with the starting amount times 1/2 raised to the power of the number of half-lives. Okay? And that will equal the amount remaining or the ending amount. Okay, you could use either term. So we have 7.2 divided by 2.4, because it's 7.2 minutes past, each half-life is 2.4, gives us 3 half-lives. So now we're going to take our starting amount, which is 100.0, multiply that times 1/2 raised to the third power, and that should equal our ending amount. Well, 1/2 times raised to the third power is 0.125, so 100.0 times 0.125 gives us 12.5 grams remaining. And that is a simple half-life problem.